This is exercise 6.1a, question 9. The line r equals -2, 3, 4 plus t times 4, -1, -2 lies within the plane pi, and we're told that the point A, 3p plus 5, 5p, and 6 minus p, also lies in pi. And then part A asks us to find an equation of pi in terms of p. Alright, and let's just check that this point A is not on the line R. Alright, so R is equal to -2, 3, 4 plus t times 4, -1, -2. Okay, and A, well, let's write this as -2 plus 4t, 3 minus t, and 4 minus 2t. Okay, and then the points, well, the position vector OA is equal to 3p plus 5 and 5p and 6 minus p. So we don't want there, so R is in terms of the parameter t, we don't want there to be any value of t or p where these things are equal. And just, for example, looking at the second coordinate, we would, if they were equal, we would have to have that 5p is equal to 3 minus t. So that would mean that t is equal to 3 minus 5p. Okay, and so putting that into the first equation, we would have -2 plus 4 times t, so plus 12 minus 20p is equal to 5 plus 3p. So we would get 23p is equal to 5. So that would mean that p is equal to 5 divided by 23. And then also that t is equal to 3 minus 25 over 23. Which is equal to 44 over 23. And substituting those values in for t and p to the last coordinate shows that this solution is impossible. So there's no values of p and t for which this point is on the line. Okay, that's great news. That means we're ready to start the problem. Okay, so we got our plane pi, and we got our line R. So R is equal to -2, 3, 4 plus t times 4, -1, -2. And then we got our point A over here, and it has coordinates, well, let's just say the vector OA is equal to 5 plus 3p, 5p, and 6 minus p. And then we got our origin O over here. And then we got 2 points on this line. Let's call it B, so that the vector OB is just equal to -2, 3, 4. So that's taking t equal to 0. And then we can also get one taking t equals 1. So that would be OC. So t equals 1 gives us -2 plus 4, so 2, 3 minus 1 is 2, and 4 minus 2 is 2. Okay. And we're pretty much ready to go now. The equation of our plane is going to be r of lambda and theta. Wait, what? Theta? Lambda and what's the other one they usually use? Mu, not theta. Okay, and that's going to be, we can just say OA, so 5 plus 3p. You know what, I think OA is actually a bad choice because we're going to do more. If we choose OA to be our initial vector, then we're going to have more to do with p. So let's take OC to be our initial vector this time, and we can then take the vector CA and CB. Okay, so OC is the vector 2, 2, 2. Okay, plus lambda times CA, which is OA minus OC. So that will be 3 plus 3p, 5p minus 2, and 4 minus p. Okay, so this is OC plus lambda times CA, and the last one is plus mu times CB, which is OB minus OC, so it'll be negative 2 minus 2 will be negative 4, 3 minus 2 will be 1, and 4 minus 2 would be 2. So this would be CB, OB minus OC. Okay, so that is the equation of our plane in terms of P. For the next part, we are also given that this point B with coordinates 2, 16, and negative 8 is also on pi, and then it just says to find P. Not a problem. Okay, so we got this vector that's on the plane. So r of lambda mu for some values of lambda mu is equal to 2, 16, negative 8. Because that point is somewhere on the plane. Okay, so we have, just expanding this out a little bit, so we have this thing is equal to 2, 2, 2 plus lambda times 3 plus 3p, 5p minus 2, and 4 minus p, plus mu times the other one, negative 4, 1, and 2. So bringing this 2, 2, 2 to the other side gives us 0, 14, and negative 10 is equal to, and let's just expand everything out now and put them all into a single vector. So that would be 3 lambda plus 3p lambda minus 4 mu. And then we have 5p lambda minus 2 lambda plus mu. And then we have 4 lambda minus p lambda plus 2 mu. So we got 3 equations, and I mean, I guess you can just call p lambda something else, because you got 3 linear equations and 3 unknowns. So let's just say p lambda is equal to w, and then so you're just writing this out as a matrix. So let's say lambda in the first column, so 3, negative 2, and 4. And then let's say mu in the second column, so that'll be negative 4, 1, and 2. and then p lambda in the third column, so that will be 3, 5, and -1. And I think we call p lambda w. So lambda mu w. So this thing is equal to 0, 14, and -10. And you can solve this however you like. You can use matrix inversion if you want, but it's probably just faster to do this on the calculator. Your calculator is set up to solve this thing. So on most calculators you can get there by going menu and then equation and then select simultaneous. So simultaneous equations. And then it will ask you to select the number of unknowns, which in our case is 3 unknowns. And then you'll get a big matrix structure where you can type in the appropriate values. And so solving that, we get that lambda is equal to -2, mu is equal to 0, and w is equal to +2. And since w is equal to lambda times p, we must have that p is equal to -1. So that's all for that question.